All right, this video is going over how to rationalize a radical. It's one way to divide radicals, but you're never allowed to have a radical on the bottom of a fraction. So we are going to go ahead and rationalize or show a way in which you don't have a radical on the bottom of the fraction. So like just keeping it simple, let's say we've got 1 over the square root of 3. Okay? We cannot have a radical in the bottom of the fraction. So the way to rationalize it is to multiply the numerator and the bottom by 1, disguised as radical 3 over radical 3. If I were to divide those, it just goes to 1, it cancels. So we are going to multiply 1 over the radical 3, or square root of 3, by 1, disguised as radical 3 over radical 3. Now when I do this, let's go ahead and write this out. So I get 1 times square root of 3, that doesn't really change, divided by, these two I'm able to multiply together, and so I get the square root of 3 squared. These two end up going inside the same house or the same radicand sign. The index here is now the same as this number here, so they're going to cancel. I'm able to take a 3 out, and so this gives me the square root of 3 divided by 3, and now there's nothing inside of that radical sign, so I can get rid of it. And I'm now left with square root of 3 divided by 3. There's no radical on the bottom, and so this is a legal answer. I'm not going to get thrown in jail for this one. And so I've just rationalized this. There's now no radical on the bottom. Let's do another one just to kind of show how this is working. We're simply multiplying both the numerator and denominator, the top and the bottom, by whatever that radical sign is. Let's go with 4 divided by the square root of 5. Okay? Very similar problem. I can't have a radical on the bottom, so I multiply the top and the bottom by the same exact thing. So that way the bottom is just going to become the square root of 5 squared, because it's multiplied by itself. Those cancel, and I just get 5 on the bottom. The top, it's going to stay 4 times the square root of 5 because I can't multiply those together. 4 does not have the same index number. It's not even inside of a radical. So that would be as far as I can go. Now it can get kind of messy when you end up with problems like this where it's not just a multiplication on the bottom with a radical sign. Now I have one that has like 3 minus a radical. So I'm not going to just multiply the top and the bottom by radical 7. Let me show you what would happen if I do. If I multiply the top and the bottom by radical 7, this bottom piece ends up having invisible parentheses that have to get put around that. And then I would multiply this times both pieces. So square root of 7 times the square root of 7, those would cancel and just become a 7. But when I distribute it to this 3, now the 3 ends up with a radical on it. And there's still a radical on the bottom. So that little strategy doesn't work. Let me rewrite this so it's clean. So the way to rationalize a fraction like this, when there is a plus or a minus in the middle, is to multiply the top and the bottom by the same exact polynomial. We are going to multiply the top and the bottom by the same expression, except we're going to change the sign in the middle to be the opposite. If this was a minus, then these are both a plus. If this is a plus, then these are both going to be a minus. So in this case, I need to have pluses or addition signs. And the reason for this is when I end up distributing, all of the radicals are going to end up canceling. So let's just show how that works. So when I have 3 times 3, I get 9. When I get 3 times the square root of 7, that's just going to stay a positive 3 square root of 7. But here's where things start canceling. Right here I have a negative square root of 7 times 3, so that's going to be a negative 3 square roots of 7, which you'll now notice those two things are opposites. They're going to cancel. So I have 3 square roots of 7 minus 3 square roots of 7, they're going to go away to 0. They both cancel. And then last but not least, when I multiply here, in fact, let's just cancel that. They're gone. Now when I do the last little bit of this, negative square root of 7 times positive square root of 7, the square roots cancel because I get 7 squared, and I get minus 7. Again, negative square roots of 7 times a square root of 7 is negative square root of 7 squared. The square cancels the root, and I just have a negative and a 7 left over. And so I just get a negative 7 right here. And this always happens when I rationalize. All of the square roots are going to cancel. And the shortcut of this is just all you have to do is square this number and get 9. Square this number, which will cancel the radical, and then subtract. It's always going to be a subtract. So it's going to be minus that number. Okay, and then I just have to deal with the top. So I get 9 plus 3 square roots of 7. This bottom part, 9 minus 7, is just 2. And there we go. We have just rationalized this problem. That was a little quick. Let's do another one. Usually it helps to see a couple. All right, let's try this one. We've got radical 3, or square root of 3, divided by 5 plus the square root of 6. So I'm going to multiply the numerator and denominator by 5 minus the square root of 6 on both the top and the bottom. All right. Now I know the shortcut to this. So the shortcut is just going to be square this and get 25. Square this, which will cancel the radical, and just get 6. And then subtract those two. That's the shortcut. But let's show this again, just to kind of help solidify this in your mind, how this works. When I multiply this together, 5 times 5 is 25. That's where that comes from. 5 times negative square root of 6 would be negative 5 square roots of 6. When I multiply here, I'm going to get the positive version. Square root of 6 times 5 is plus 5 square roots of 6, so they cancel each other and go away. That's why it's not over there. And then last but not least, square root of 6 times negative square roots of 6 is negative square roots of 6 squared. The square cancels the radical, and so I'm just left with the minus 6. Okay, now I just subtract those, and I would get 19. So I have so the bottom of the fraction would be a 19. The top, I need to multiply this in. See if I can reduce this at all. I get 5 square roots of 3 minus, I'm going to do a little scratch work on the side, square root of 3 times the square root of 6. Okay, well, they both have the same index, so I can put them together. I get square root of 3 times 6, which is 3 times 2, 3 squared. I could take a 3 out, so that's going to be 3 square roots of 2. Now, are they like terms? Am I able to put them together? No. The insides have to be the same, and they're not. So that would be my final answer. I also can't reduce, can't divide both of those by any factors of 19, so that would be as far as I can go. All right, that's just a basic lesson on how to rationalize radicals. If there's anything I can do to help you, let me know. Leave a comment in the section down below. Give this channel a subscribe and a like, and we'll see you soon. Have a good day.